Hello everyone, Kainat here. So here we will discuss my topic common catenary. So I'm gonna explain this topic. So here what is first we have to understand that is what is common catenary. So whenever a uniform flexible string means if I take a uniform flexible string like this and it is freely hang between two points which are not in the same vertical plane, which means that here its one point is at point A and the other end is fixed at point B, so they are not in the same vertical plane. Okay, so this is our any rod or string, okay, this kind of thing. So here we will make the full diagram of this. Okay, so this is our y-axis and this is our x-axis. In common catenary, the x-axis is known as directrix, and the y-axis is known as the axis of catenary. Here the distance the length between these two fixed point is known as our span. Here this length is equals to x and also this length is equals to x, so overall this span will be equals to 2x. Okay, and next thing, this point is known as the lowest point of catenary, because this is the lowest point, so this is known as the lowest point of catenary, and this is known from point D. Let us consider this point D. So from D to C it is our sag, it is known as sag, this. Okay, and this is the lowest point of catenary where the value of x-axis will be 0, means our x coordinate will be 0 and y will be C, because this point is C, and here it will be O. Let us consider O. So our sag will be equals to, means sag हमारा बराबर हो जाएगा, we will take the whole length, that is OD minus this length OC. So we can write this as sag equals to OD, this is our y-axis, so we will take it y, and OC which is equals to C and I-axis. So our sag will be equals to y minus C. Okay, so if I take a point S on this, consider this as point S, so here the arc है ना, this arc CS, हाँ, तो जो arc होगी हमारी CS, here at point C there will be tension T0 which is equal to WC. T0 will be equal to WC, and here at due to this arc some weight must be considered, we can consider some weight. So I am drawing a tangent through this, tangent at angle psi, and if we will divide this angle psi into two components, then this will be our some bigger T cos psi and T sin psi. Okay, and WS weight is acting here, WS. So again, taking the overview of this catenary, we have taken a catenary which is fixed at 2 points that are not in the same vertical plane, and the length of the weight per unit length of the string is constant. So this is our this becomes a common catenary in which the distance between the two fixed point is known as our span, which is equals to 2x, and the distance from this from the lowest point of catenary to the highest point is known as our sag, which is equals to y minus C, which we have derived, and at point C the tension is T0 which is equals to weight WC, and at point S due to the arc CS await ws is acting, which is ws. Okay, and where and here we have taken a tangent which is equals to psi, and we have break it into two components, t cos psi and t sin psi. Now we will derive the intrinsic and Cartesian equations of the common catenary. So now we will derive the Cartesian equation of catenary. So we will consider the catenary is in equilibrium position. So if the catenary will be in equilibrium position, then our t cos psi, here t cos psi will be equals to wc, or we can say that with which is equals to the tension, that is t naught, and our t sin psi will be equals to ws. Okay, so here we will write these two equations which I have put forward, that is t sin psi is equals to ws, which is our first equation, and t cos psi is equals to t naught, and which is also equals to wc, right, which is our second equation. Dividing both these equations, we will get t sin psi upon t cos psi equals to ws upon wc. We will take this wc, not t naught. Okay, so here t and t will be cancelled out, and we know sin upon cos equals to tan, so tan psi equals to ws upon wc. We will transpose wc to the left side, so wc tan psi equals to ws, and we can write this as s. We can write ws as s and wc as c, so s equals to c tan psi, which is our Cartesian, this is our intrinsic equation, which is our intrinsic equation of common catenary. Now we will derive Cartesian equation of common catenary. Cartesian equation of common catenary. So for this, we know that our tangent psi, which is our slope, so we can write tan psi equals to dy by dx. Tan psi equals to dy by dx. Okay, so from our previous equation, that is s equals to c tan psi, that is our intrinsic equation, we can write s equals to c tan psi. So putting the value of tan psi, that is the slope, so s equals to c dy by dx. Okay, so differentiating this equation, let us consider this equation a. So we have considered this, and now we are differentiating the equation with respect to x. So we will get ds by dx equals to c and d2y by dx2. So here I am generating a triangle from where we will get the value of ds by dx. So here we know that this is equals to ds, and the angle is psi, and this is equals to dy, and this is dx. So from Pythagoras triplet theorem, we know that ds square equals to dx square plus dy square. Sending the square this side, we will get ds equals to dx square plus dy square under root, and dividing this equation by dx square. No, 1 second. We can do this like not sending the root this side. We can first divide the whole equation by dx square. So ds by dx square, ds by dx whole square equals to, this will become 1. When we will divide this dx whole square by dx square, we will get 1, and here dy by dx whole square. Now sending the square this side, then we will get the value of ds by dx, that is equals to root over 1 plus dy by dx whole square. Okay, now putting this value here, we will get 1 plus dy by dx whole square whole under root equals to c d2y by dx square. Now sending the root to the right side, we will get 1 plus dy by dx whole square equals to c square and d2y dx square. So to remove the complication, we can let dy by dx equals to p. So we can put the value in this equation. We will get 1 plus p square. 1 plus p square, we will take this root this side only, so we will get 1 plus p square under root is equals to c dp by dx. This term will become dp by dx. We will cut this term. This is not needed. We have considered dy by dx equals to p. So here dy by dx, we will put the value for dy by dx equals to p. So here we will get under root 1 plus p square equals to c, and for d2y by dx2, we will get dp by dx. Okay, next we will transport the values. So we will again write the equation. So c dp by dx equals to root over 1 plus p square. So we will send 1 plus p square this side and dx by c that side. So dp upon 1 plus p square under root by c equals to dx. Integrating both side, we will integrate both side. So here we will get, on integrating, we know that the integration of 1 upon root over 1 plus p square is, c is constant, we will write this as it is. So sine hyperbolic inverse p, the integration of this will be sine hyperbolic inverse p equals to, and integration of this will become x, and constant is a. Okay, so here we will find the value of a. So at lowest point, matlab at point c, we know the value of x is 0 and the value of y is c. So x will be 0 and dy by dx will also become 0 because c is constant. So putting this value here, we will get, because p's are dy by dx, so we will put as dy by dx equals to 0, so p equals to 0. तो c sin hyperbolic p की जहाँ पे 0 equals to x यहाँ पे 0 plus a. So this will become 0 because its value is 0. So a will be 0. So putting this value in this equation, so c sin hyperbolic, so p is equals to dy by dx, so we will take that only, dy by dx equals to x plus 0. This is not needed. We will transpose this c this side, so sin hyperbolic inverse dy by dx is equals to x by c, and sending the sign hyperbolic that side, so this will become dy by dx is equals to sine hyperbolic x by c. Again sending dx this side, we will get dy equals to sine hyperbolic x by c dx. Now again integrating both sides with respect to the, so dy equals to y, integration of dy is y, and integration of this will be cos hyperbolic x by c, plus the constant, that is let the constants be d. So now again finding the value of d again at the point, at the lowest point of catenary, that is at point c. We know x is 0 and y equals to c, है ना. So also one thing is missing here, one thing is missing, that is it will be equals to the missing thing is when we will integrate this portion, that sine hyperbolic x by c, we will get cos hyperbolic x by c, and as c is constant, then it will come here, है ना. Okay, so we know that at x equals to 0, y equals to c, so putting at y equals to c equals to this c, and we know that cos hyperbolic x by c, putting at x equals to 0, we know cos hyperbolic x cos hyperbolic 0 is 1, so we will write this c plus d, so c is cancelled, so d equals to 0. Again our constant term is 0, so putting this in this, putting the value of d in this equation, we will get y equals to c cos hyperbolic x by c, which is our Cartesian equation of common catenary. Thank you.